Topic 1.4 looks like a monster, but after going through every practice and AP exam question, I found out it really only covers 3 questions. They involve graphical data, experimental error, and particle diagrams. So here's the thing, don't just memorize these 3 questions, understand them, because these same concepts keep showing up unit after unit for the rest of the course. Stick around, because I'm about to break down all 3 question types, show you the variations College Board loves to throw at you, and teach you the skills you'll be using in every single unit from here on out. Let's start with the graphs. This is a typical AP question introduction. There's a graph and a bunch of background information about an experiment, and this doesn't include the actual question. When any questions give me this much information, I usually skip straight to the question. There's even more intro. Here is the actual question. I'm looking for the mass of zinc in the sample. Now that I know what I'm looking for, let me work backwards. What's my connection to the zinc? I'm told it's a 0.325 gram sample, but I don't have a link between the zinc and the sample. What else do I have? The pressure of hydrogen. Do you see the link between the pressure of hydrogen and the mass of zinc? It's the graph. Sometimes you got to look around and see where your connections are. Since I know the pressure of H2, I start at the vertical axis. There are lines at 0.06 and 0.08, so 0.07 will be right in the middle. Draw that out till it reaches the line and then down to the horizontal axis to find the mass of zinc. That intersects the axis to the left of 2, which means C is the correct answer. Time is a factor on the AP exam, and questions tend to provide you with a lot of information. Read the question, find the information you need, then move on. A quick comment about practice. There was a specific note on the 2025 Chief Reader Report, the guys who grade the exam, that said that students should be capable of reading points on a graph that do not fall on a grid line. Make sure you have access to graph practice that doesn't always fall nice and neat on the lines. You're going to want to practice that before the actual exam. The next question relates to the graph, but asks for the percent by mass of zinc in the mixture. I covered a universal approach to percentage problems in my 1.3 video. Percentages can be dropped into just about any topic on the AP exam. I suggest watching that one if you haven't already. To calculate the percent of zinc in the mixture, I'll write the mass of zinc in the numerator and the mass of sample in the denominator. The mass of zinc was calculated in the previous problem as this, and from the top I see that the mass of the sample was 0.325 grams. Don't forget to multiply by 100, and that's about 58%, which matches option B. The last thing I want to mention about this graph is the outlier in the data set. Can you see which point is inconsistent with the others? It's this one, slightly below the trend line that runs very close to all the other data. This represents experimental error. The dot being too low indicates that the pressure of H2 produced in the experiment is lower than it should be. This could be because some zinc was lost or didn't react for some reason. Maybe some of the H2 leaked out of the container, reducing the pressure. Always consider the possible sources of error for any experiment. There are usually 2 to 3 of these that you'll need to explain in the free response section, and they're also likely to appear in the multiple choice. Which brings me to the next main question. Precipitation error analysis. Another really long question. Welcome to AP Chemistry. Sometimes it can help to start with the answer choices. No, those are too long. Okay, time to dissect the question then. I have a purpose for the experiment, the result, which gives me the data, what I'm asked to find, and the error. I didn't lay this out in the last problem, but visualizing the calculation will make it clear whether the calculated values are higher or lower than they should be, and possibly why. This is all the more important because there's no numbers in this problem. Watch how much this helps. I'm evaluating the percent of calcium in the sample. The mass of calcium goes up top, and the mass of the sample goes down on the bottom. I'm not actually doing the math, but always remember to multiply by 100. That will give me the percent of calcium in the sample. Now I can see how the error will change the result of the calculation. The problem was that the precipitate was not dried completely. There's extra water in what was measured. The precipitate contains the calcium. That will make the mass of calcium in the numerator greater than it should be due to the extra water. If the numerator is too large, the percent of calcium will be 2. I'm going to say that the calculated value is greater than the actual value. Clearly, distinguishing between calculated and actual is very important. Now that I've decided what the answer is, I can look at those long choices and pick the best one. A, calculated percentage is too low. No. B, the calculated percentage is too low. No. C, the calculated percentage is too high. That works, but let me check the last one before I move on to the next question. D, the calculated percentage is the same. Nope, that's out too. Just in case I'm wrong, I'm going to make sure that my justification matches option C. Additional water increases the mass of precipitate, so higher mass of calcium in the sample. That's exactly what I put on paper, so now I'm confident in my answer. You can be efficient in your process and skip reading things that you don't have to, but take the time to confirm that your choice is completely correct before moving on to the next question. Efficient and careful wins the race. I don't think that's really what the turtle said, but I'm going to go with it. There will likely be a few error analysis questions that can be connected to any of the experimental techniques discussed on the AP exam. As you study the different experiments this year, make note of the possible errors you're likely to be tested on. Last one on my list is the particle diagrams. Finally, a short question, but there's still a trick here. By asking you for a comparison of percent composition, this seems like a math problem, but you won't need a calculator to solve this one. When comparing graphs, images, or diagrams, I always start looking for the differences. I'm focused on the oxygen, which is in every diagram. There's a similar number of particles in each box, but the two on the left contain oxygen and hydrogen, while the two on the right contain oxygen and carbon. There's a difference. The molar mass of carbon is about 12 times the mass of hydrogen, so the boxes with the hydrogen in them have a greater percentage of oxygen by mass. If you don't see that right away, you can still set up the calculations without any numbers. To calculate the percent oxygen in the mixture, I'd have to divide the mass of oxygen by the mass of the mixture. The mixtures contain different elements, so the denominators are different for each pair of diagrams. Hydrogen has significantly less mass than the carbon, making the denominator on the left smaller than the one on the right. Dividing by a smaller number will result in a larger percentage of oxygen. That means I can eliminate the boxes on the right that contain the carbon. Expect to do a lot of this type analysis on the AP Chem exam. If that made your head hurt, go back and try thinking through it on your own and make sure you work some practice that applies those techniques. Now that I'm dealing with mixtures containing the same elements, it's time to count particles. There are 4 representations of oxygen in both, so I only need to worry about the hydrogen. There are 8 in the box on the left and 6 in the box on the right. If I want the greatest percentage of oxygen, I want the least amount of other stuff, right? Smaller denominator gives you a larger percent. If you need the practice, set up the equation and confirm this number. But that means the diagram with the largest percent oxygen by mass is the second one. And there it is. 3 main question types that appear totally different, but all apply percent composition by mass to mixtures. Keep in mind that the writers of the AP exam put a lot of effort into writing these questions in new and unique ways. As you practice these, take note of the concepts behind the material and the thought process necessary for solving each one. Get some practice on things like this so you can train your brain. If you made it this far, thank you. I've created this channel because there's nothing better than watching a student go from confused to confident. So if this helped, please hit subscribe. I'm building out over 100 videos to cover every topic in AP Chem this year, and every subscriber tells me it's worth finishing. And remember, don't just memorize it, understand it.